Hello guys, so today we try to do a 6Q kata. Let's get to know the exercise. Sum of prime indexed elements. In this kata, you will be given an integer array and your task is to return the sum of elements occupying prime numbered indices. The first element is at index 0, let's get to know. So we are returning the sum of the elements occupying prime numbered indices. If you look at this example here, this one here, it starts at index 0, so I have 0, 1, 2, 3. So this is an array of indices running from 0 to 3. Now, from 0 to 3, what are prime numbers from 0 to 3? 2 is a prime number and 3 is a prime number. So these two numbers highlighted here occupy index 2 and 3, which are prime number indices. So we have to return the sum of those numbers. So we return 3 and 4, that's when we have 7. If we take this example below, we have indices running from 0 to 5. So 0, 1, 2, 3, 4, 5. So index 2 and 3 are prime numbers. Also index 5 is a prime number. So here will be 3 plus 4 plus 6. That's where we get this 13. That's basically it. So that means in order to solve this algorithm, we should have a list of all the prime numbers involved, prime indices. For example, here, if I take this example, we have 7 indices run from 0 to 7. So we should have a list of primary numbers from 0 to 7, something like that. And then when we come to this array we get those prime number indices and do the sum of whatever integer is there. Right. I happen to know there's an algorithm called Sieve of Eratosthenes. Let's see, Sieve of Eratosthenes. Alright, we'll learn about that today. Now this is something you just have to know code. It's the name of an algorithm that returns a list of primary numbers. Of prime numbers. Why do I keep saying primary? Prime numbers. Let's just say it on the search engine. I'm using DuckDuckGo. So what is this? Sieve of Eratosthenes. In mathematics, the Sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to a given limit. And in our scenario, our limit is going to be the length of the array. Alright. It does so by iteratively marking as composite the multiples of each prime. Basically, you can Google and see the algorithm and study and execute it. Look it up on YouTube, no problem. So I'll get the algorithm in Javascript. Without this algorithm, we will have to generate the prime numbers ourselves. So in JavaScript, let's get this one from Stack Overflow. Okay, we got an answer. Below is a sieve of Eratosthenes following conventional programming practices. Well, this is Javascript. Eratosthenes algorithm to find all prime numbers under n. Well, let's try to execute this algorithm to be sure that it works. If I go to my node console, I just paste it there and run it. Okay, now there's a return. Okay, so let me call the algorithm on, let's say 7. So we have the list of prime numbers under 7. What about up to 15? This is a list of prime numbers under 15. So this algorithm works. So you can look at it, and I'll put the link of this link on the description of the video. Basically, this is the algorithm. You can study it if you want, but you know what it does. It returns a list of primary numbers under n. Okay, I'll bring it to Codewars and just put it up there. Alright, now here, what do? We need a list of, let me just put it into a variable. We need a list, let's just call it prime list. There's a list of prime numbers. From under n, and what is n this time? Is the array dot length. So let's be careful. It returns under. Now, what is the length of this array? For example, 1, 2, 3, 4. There are 4 elements, so it's going to return 2 and 3, which is good for our case. Okay. So here we have the list of prime numbers. Yeah. Now we'll have to look through this array and get all the indexes that are inside this prime list and sum up the number there. Okay. So let's just create a variable that will have our sum. Let's put it at 0, and let's look through our prime list. But for each, we probably cheated a little bit. I was lucky that I knew this algorithm. Else you have to code it. You have to code it yourself. So I look through each. Inside this prime list, we have, let's say, we have a list of indexes. But actually, we have a list of prime numbers. Okay. So we look through that prime list, and this prime list corresponds to indexes that are inside our array. So inside our sum, we are going to add the element that is inside the array at the index of the prime number. At the end, we return sum. Oops, we got an error. Return with n. Alright. And we are good to go. So this was a harder task, and it happens that we know what it is. So this is the algorithm of Eratosthenes. So guys, don't forget to check it out. I'll put the algorithm in the description. There's a whole video on YouTube for this. So